So I'm going to find the exact value of the sine of arc cosine 1/2 plus arc sine of 3/5. Okay? So I'm going to recall that these two things right here are angles. I'm going to call that alpha and this beta. So alpha equals the cosine inverse of 1/2. Then that means the cosine of alpha is equal to 1/2 as long as alpha is between 0 and pi. And beta is equal to the sine of inverse of 3/5, means that the sine of beta is equal to 3/5 for beta between negative pi over 2 and pi over 2. Okay, those are the restrictions on the arguments for the inverse functions. Hopefully you got that down. Remember the cos and then the sine and then tangent over to the side, right? Negative pi over 2, 0 to pi for cosine, and then not including the endpoints of the interval, negative pi over 2 and pi over 2 for tangent. Okay? So I can draw a triangle, all right? And so alpha is in quadrant 1 or quadrant 2. Since cosine is positive, I know that my triangle is in the first quadrant because all students take calculus, right? So cosine would be negative over here, but since it's positive, it's in the first quadrant. So cosine of my angle alpha, cosine, what is cosine defined to be? It's x over r. So that's 1 over 2. So how do I get this other side here? This y value is Pythagorean Theorem. 1 squared plus y squared equals 2 squared. So 1 plus y squared equals 4. Subtract 1. So I have y squared equals 3. Now, y is greater than 0, so when I take the square root, I'm going to use the positive square root of 3 for this right here. Okay, so this is the positive square root of 3. Okay. So what does that tell me? Well, that tells me a little bit of information. It tells me what the sine of alpha is now. The sine of alpha for alpha, opposite over hypotenuse, which is square root 3 over 2. Okay. For my other triangle over here, beta is stuck between negative pi over 2 and pi over 2, but since sine is positive, I know I'm in the first quadrant. So sine is y over r, so 3 over, and then I have my 5, and so I'm looking for a positive x value. Okay, so x squared plus 3 squared equals 5 squared. So x squared plus 9 equals 25. Subtract 9. I get x squared equals 16 square root. I get plus or minus 4. Since it's positive, I'm going to have a positive 4 here. And that's for my beta angle. Now, if I want the cosine of beta, what is cosine? It's adjacent divided by hypotenuse, which is 4 divided by 5. So now I think I have all the parts that I needed. Okay, so what am I going to do? I'm going to calculate this right here. Okay, so how do I do that? So the sine of cosine inverse 1/2 plus sine inverse 3/5. Okay, what is this equal to? Think of that as sine alpha plus beta, right? Because I call this alpha and I call this beta. So what's the formula say to do? The addition tells me sine alpha cosine beta plus cosine alpha sine beta. Okay? So what does this equal? Well, I've got all the pieces right here, don't I? Everything I needed to know right there. So the sine of alpha, square root 3 over 2. Cosine of beta is 4 over 5. Plus the cosine of alpha, which is 1/2, times the sine of beta, which is 3 over 5. So this is going to be, well, these 2's cancel, get 2 here and 1 there. And so I get 2 square root 3 over 5 plus 3 over 10. If you really, you were itching to get a common denominator, you could multiply top and bottom by 2. And you'd end up getting 4 square root 3 plus 3 over 10. I would probably be okay with that answer, but if you want to get a common denominator and make it look like what the back of the book says, that's fine. Okay. This next one, we're going to be writing trig expression as an algebraic expression. And when you get to calculus 2, you're actually going to be taking an algebraic expression and turning it into a trig expression. So you'll be going backwards. So what I want to do is I want to write sine of sine inverse u plus cosine inverse u, or let's do v, they've got a v, all right, as an algebraic expression containing u and v. So let's set this first piece here to be alpha, and the second piece here we'll make it beta. So the sine inverse of u equals alpha, then that means that u is equal to the sine of alpha, okay, as long as alpha is stuck between negative pi over 2 and pi over 2, okay, and then the cosine inverse of v is equal to beta, so that tells me that v is equal to the cosine of beta for beta between 0 and pi. Just those restrictions that we talked about just a little bit ago. Okay? So what does that tell me with my triangle, right? So if I run through this game again, right, I'm going to have sine sum identity. Okay, what does the sine sum identity say? It says the sine of sine inverse u times the cosine of cosine inverse v, okay, then plus the cosine of sine inverse u times the sine of cosine inverse v. Okay? So how do we do this, right? That's the question. And you might be asking yourself, well, where in the world did that even come from? Well, it came from the identity. If we were using alphas, it would look like this. Which maybe you see now. So that's sine alpha plus beta. Okay, see, we called these alpha and beta. Okay? So the sine of sine inverse of u is simply u. And the cosine of cosine inverse of v is simply v. So it's u times v. Okay? Now, this is where it gets a little tricky. The cosine of cosine inverse u. Now, the cosine of cosine inverse u. Let me get rid of this because I, didn't really need this. Maybe I'll put it down here. Okay? So for those looking at their notes later, they're wondering where those pieces came from. All right, so this triangle, okay, sine of theta, or sine of alpha rather, okay, sine is opposite over hypotenuse. So to get this other side here, we got to use Pythagorean Theorem. So that question mark squared plus u squared equals 1 squared. So whatever it is squared, and then I subtract u squared from both sides, that's 1 minus u squared. But then I take the square root, okay? So when I take the square root, I know cosine, all right, when I'm restricted to pi over 2 to pi over 2, it's positive. Cosine is positive, so I know I'm going to have on the plus or the minus, I take the positive one. So this becomes the positive square root 1 minus u squared. Okay? And then for this right here, the sine of cosine inverse of v, well, how do I draw this triangle? Well, that triangle, cosine of beta, cosine is some old hippie, cot another hippie adjacent, that's v over 1. So that means using Pythagorean Theorem, I can get 1 minus v squared here, okay? And I know this is positive because for sine, sine is positive in the first and second quadrants. So I know that that's the positive branch for that part right there. Okay, oh, that's not a v, that's a v, not a u. Okay, so my answer is uv plus square root 1 minus u squared times square root 1 minus v squared. Okay, so that's a pretty nasty algebraic expression, but that is the algebraic expression for this nasty trig expression here. And that's going to do it for this video.